Okay, so this is the second video for section 4.1, and the last one. It's not going to be a very long video section, but here's the thing. We're about to start verifications. Identity verifications is what it's called. Now, this will pretty much persist throughout the whole chapter. Now, we're going to just do a few simplifications now, but we'll get to the point where we actually check them. So, a verification, this is actually checking. We're not going to be checking yet. We're just simplifying right now. Okay, so we're going to edge you into this a little at a time. Section 4.2 will actually do some checking. Okay, so here's where knowing your identities is going to come in handy. Okay, and the first day when I'm in a calculus class, if I'm in Cal 1, I always say this. I say, students, calculus is not a math class. And everybody looks at me real funny that first day like I'm crazy. And I tell them calculus is a problem solving and manipulation class. Being an engineer is not a math profession as much as it is a problem solving profession and a manipulation profession. Okay? So you've got to be able to manipulate these identities and formulas any way you can to help you simplify the problem. That's going to be the goal. So for instance, 1 over cosine squared alpha minus 1. So we want to simplify this. Well, so far not so good. So far I see no simplification that is really going to be of benefit for us yet. Okay, well I do, but we're going to go a different route first. So let's get a common denominator. Okay, so the common denominator would obviously be cosine squared alpha, and so this would be a 1 minus cosine squared alpha once you got the common denominator and combined it into one fraction. Now here's where knowing your identities is going to come in handy. This part right here, this part on top right here, this is actually, folks, this is actually your Pythagorean identity. Sine squared x plus cosine squared x equals 1. I know that's hard to believe, but it is actually that one. Because all they have done is they have subtracted cosine x from both sides. And so sine squared x equals 1 minus cosine squared x. So see how, this is what I'm talking about with manipulation. You see how I manipulated that identity to get what I needed? Now that I know what 1 minus cosine squared x is, I can directly substitute in. So sine squared x over cosine squared. Well, it should be alpha, not x. It should be alpha. Okay? Sine squared alpha over cosine squared alpha. Now, at this point, in your mind, what you should have is, what is sine over cosine? Well, hopefully it's clicking right now. That's tangent. Well, since this is sine squared over cosine squared, that's the same thing as tangent squared. Okay? Sine over cosine is tangent, but since this is sine squared over cosine squared, that's the same thing as tangent squared. Okay? And that's our final answer. We've simplified it as far down as we possibly can. Now, as we progress on, there are some of these problems that we could probably work 10 or 15 different ways, honestly. So some of you may have completely different answers or ways of working it than I do. I've even been grading papers in class before and graded the student's paper and said, wow, I didn't even think about working it that way. So there are tons of ways you can solve these problems. Case in point, same problem. Case in point, 1 over cosine squared. Well, what's 1 over cosine? 1 over cosine. What is 1 over cosine? One over cosine. Well, 1 over cosine is secant. So 1 over cosine squared would be secant squared. Everybody see that? 1 over cosine is secant. And I wrote x again when it should be alpha. I have a hard time with alphas. Okay, so now that's just your basic reciprocal identity there. 1 over cosine is secant. Now here's why. This is the way I would have solved it initially. Because here's why. Most everybody, when I say Pythagorean identities, they think of this right here. And that's the only one that people think of. Well, there are actually 3 Pythagorean identities. There's one that relates sine and cosine, one that relates tangent and secant, and one that relates cotangent and cosecant. So look at this. There is one that relates tangent and secant, and it says that tangent squared x plus 1 equals secant squared x equals secant squared x. That's another Pythagorean identity. Okay? So, notice what they did. If you subtract 1 from both sides of this, you get tangent squared x equals secant squared x minus 1. Well, look what we have up above us. We have secant squared alpha minus 1. So what does secant squared alpha equal? Well, secant squared alpha equals tangent squared alpha. So see, that's 2 different ways of getting to the same answer using 2 different identities. Okay? So you've got to be able to manipulate that. Now, the only way to do this is to work problems. More problems than I give you for homework. So I would not only work the ones I give you online, I would turn to the section in the book and work the odd ones, since the odd ones are in the back of the book. I would make sure and work as many of these as I could get my hands on if I were you. Okay? The more practice you have, the more you're going to be able to see these different manipulations and different ways of going about solving this problem. Because if you notice, the second way is a lot easier than the first way. Okay? The second way is much easier than the first way. Alright? Well, let's look at one more example, and then we'll be done with this section, because there's only so many examples. There's an infinite number of examples I can give you with this, and nothing's really going to help other than you getting out there and practicing it. So I'm just kind of trying to give you some ideas here. So here is, well, let's go to the next page. We don't want a whole big line. So here is here's our problem. Let's say tangent x minus cotangent x all over tangent x plus cotangent x. Okay? So the first thing I do is I'm going to excuse me. I'm going to read the directions. And the directions tell you this. Write in terms of sine and cosine. So they want you to take tangent and they want you to simplify. They want you to simplify this problem, but they want you to simplify it in terms of sine and cosine. So first things first, let's change it back. What is tangent? Tangent is sine x over cosine x. What is cotangent? Well, that's the reciprocal. Cosine x over sine x. Alright, tangent x is sine x over cosine x plus cosine x over sine x. Well, we've accomplished the first part of this. We've accomplished the part that has it in terms of sine and cosine. Now it's just a matter of simplifying. And so we've got complex fractions here. So what I would do is, before I did anything else, I would look at the common denominators and see if they're the same. Because if it is, we can multiply through by a common factor. So what would the common denominator of the top be? Well, it would be sine x cosine x. What would the common denominator of the bottom be? Sine x cosine x. Alright, so they're the same. So because they're the same, I can simplify this complex fraction a little more easily than I could if they were different. If they were different, I would have to get common denominators and then flip the fractions and multiply and go through that whole long process of multiplying by the reciprocal. But because they're the same, I don't have to go through the process of multiplying by the reciprocal, because I can multiply the top by the common denominator and I can multiply the bottom by the common denominator, and I can multiply the bottom by the common denominator. And if I multiply the top by the common denominator and the bottom by the common denominator, I'm multiplying by the same thing, so I haven't changed the problem. But what does this do? Well, this kind of takes, because they're the same, this kind of takes care of your multiplying by the reciprocal, and it's going to allow you to cancel out some things. So do the distributive property. Sine x cosine x times this. So the cosine x's cancel. So I have sine x times sine x, which is sine squared x. Okay? Minus, multiply this one. Well, the sine x's cancel. So this is cosine squared x. Cosine x times cosine x. Okay? Same thing on the bottom. And when you do it, you're going to get the same kind of cancellation here for this particular problem. Okay? Now, alright, so now immediately something should jump off the page at you. What should jump off the page? Hopefully you're screaming at the screen. This right here should jump off the page at you. Why should that jump off the page? Because that's a Pythagorean identity. What does sine squared x plus cosine squared x equal? It equals 1. It equals 1. So this is really just sine squared x minus cosine squared x all over 1, which is sine squared x minus cosine squared x. Okay, so at this point, you've got to ask yourself, is there any other way I can simplify this anymore? Well, there is. Okay, we know that sine squared x plus cosine squared x equals 1. So I could very easily subtract cosine squared x from both sides, and I could get this. So, what does that tell me? Well, now I know what sine squared. I know what sine squared is. Now, so I can take this and I can substitute it in right here. And so this is 1 minus cosine squared x minus cosine squared x. Okay, so this is 1 minus 2 cosine squared x. Now, a little later on, we're actually going to have a identity for this, okay, to relate this, but you don't have it right now, so this would be your final answer. Now, what you should be asking yourself is, Mr. Francis, how did you know? It says leave it in terms of sine and cosine. Why didn't you just leave it right here? And how did you know to substitute in for sine x? Because look, I could have very easily solved this for cosine x, which is 1 minus sine squared. And I could have substituted that in right there for cosine x. And I could have gotten an answer in terms of sine squared. Then I would have gotten an answer in terms of sine squared. So how do I know? Well, they would have to tell you in the directions. They would have to tell you, write your final answer in terms of cosines. Write your final answer in terms of sines. Well, so let's suppose on this problem, the direction said, write final answer in cosine. Let's suppose it said that. It had that little attachment on it. Okay? Then we're going to get the answer we have here because it's in terms of cosine. Let's suppose it said write your final answer in terms of sine. Well, you're not going to make the substitution we made. You're going to take 1 minus sine squared and substitute it in for cosine so that you get everything in terms of sine. Okay? So you have to be careful on reading your directions. It's because you want to make sure your final answer is in terms of the right function. Okay? It's in terms of the right function. Is it in terms of sine? Is it in terms of cosine? That's what you want to make sure you read so you know which substitution to make. Because like I said, down here, we can solve this both ways. We can solve it for cosine and we can solve it for sine. So we can make a substitution for sine or cosine. So you've got to know what you're trying to get your problem in order to know which one to do. Okay? Hopefully that didn't confuse you too much. Alright, so try a few of these for homework. Make sure you practice. Section, and that's the great thing about this is section 4.2, when we get there, it will just build right on top of this. So you're going to get practice of section 4.1 in section 4.2, okay, if that makes sense. So it's going to build right on top of it. So this is our section 4.1 videos. 4.2 will be coming soon.